Hello, everybody. I am going to cover Azure 5 coding programs of Azure 5, and I will tell you in the next video that how you can install Azure 5 simulator. But before doing that, it is really necessary to know about the internal system of Azure 5, right? So, in this video is really helpful in coding as well, right? And This is the basics of Azure 5, in which I will discuss block diagram of Azure 5, right? So without delay, let's start. So it is really important to study the block diagram, right? So before coming on this diagram, let me discuss about some really basic things, right? So this is a memory. So in 805 it is 16-bit address bus and 8-bit data bus. So this thing you have to remember, that the data bus is of 8 bits and address bus is of 16 bits. So this means the memory is 2 raised to power 16 into 8, right? So what you can say that the memory has 2 raised to power 16 rows in which we can store data of 8 bits, right? And in 805, there is some space which is dedicated to stack only, and the further which remains is dedicated to programs and the data. So now you might be thinking that what's the difference between program and data? So let's say that the program is add two numbers, right? So the so I have so I am given a program that you have to write a program to add two numbers. So my data will be those two numbers. So let's say those two numbers are 2 and 3, and my program will be add 2 and 3, right? Now the stack is pointed by the stack pointer, right? And the another memory like in which we store program and data, the address is stored in program counter. So my program is starting from 0000. So I have told you that the address bus is of 16 bits. This is hexadecimal number, right? So let's say the first address is 0000. So and my program is starting from this, right? So my program is starting from this address, and the instruction is 3E. So my program counter will contain 0000. Okay, and when this is executed, the program counter will increment, and this instruction will be executed. Similarly, the program counter will again increment, and this will be executed, right? So let's come to the block diagram mainly. So the thing you should know that 8085 has 8-bit data bus and 16-bit address bus. So, and there are 7 general purpose registers. Those are accumulator, which is represented by A. Okay, and another 6 are B, C, D, E, H, and L. So these are the names provided to those registers, and all these registers are of 8 bits because data bus is of 8 bits. So the register contains data. So registers are also of 8 bits. So these are 6 dedicated general purpose registers. I mean 7 general purpose registers in which A is an accumulator, right? The thing which you should have in mind, that why this A is written separate and why these 6 registers are separate. That I'm coming on this point later, right? So we have studied about the stack pointer and the program counter, which are of 16-bit each, right? And what is this increment and decrement latch? So I have told you now that if one instruction is executed, it gets incremented. Similarly, let's say I have a stack. So my first stack pointer is here, right? And it can be downward stack also, and it can be upward stack also, right? So stack also need to be incremented or decremented, right? So that's why this increment and decrement address latch is provided. So now I've told you that our program starts with the program counter. So program counter contains the address, the first address where our program starts, right? So firstly, when we start our program, so the computer will check what's the address from where the program starts. So it will check in program counter. Now, this contains lower bits of address bus and this contain higher bits of address bus. So ignore this D for some time. So 16-bit address, right? So it starts from A0 to A15. So that will be 16-bit, right? And the program counter, then uh, this this will contain the address bus will contain the data which is contained, the bits which is contained in the program counter. Okay, so let's say the program counter contains 0000, so that will be sent in the address bus. So now what memory will send is the data from here, right? So this 3e is of 8 bits, so this 3e goes to the data bus then, right? So this instruction goes to the data bus. Okay, now this D0 to D7 represents a data bus. So here multiplexing happens. If you don't know about the multiplexing, so don't need to worry. It just means that we have 16 pins in which those 16 pins represent address bus and 8 pins out of those 16 pins represent the data bus, right? And then now when the address was sent to the memory, here is a read pin which gets active, right? So this means that we are reading from the memory, and then the data is sent through the data bus. So we came here now, right? So now this the instruction which is sent by the memory is stored in the instruction register. So the data will come here. Let me explain you this. That program counter, this 0000 is sent through the address bus, and this instruction is stored in the instruction register. Now we will firstly we have fetched this instruction from the memory. Now we will decode this, that what this instruction means, and then we will execute it. So now the next step will be to decode and execute that instruction, right? So firstly decoding happens, and this decoding goes to this main block, which is a control system of the microprocessor. So this is timing and control signal. So now firstly we decoded the instruction, and when we decode it, like the instruction is add a comma b. So let's say these are the registers, so add register a with register b. So this will tell that register A get active, register B get active. So you have to add, right? So it will tell to the ALU that ALU please be activated with the addition thing. So you have to add those registers, right? So it will control every component over here, and we have not drawn the lines to these all things because the diagram will get complicated, right? So I need to erase this. So now, next thing, okay. So this timing control will control all the system, right? Now, next thing which I have questioned you before, that why this A is separate. So you have to keep in mind that all the ALU operations which you operate have to be on register A. uh, this can be any operation like plus minus. Suppose this is plus, right? So you have to add with b, suppose. So the result will automatically be stored in accumulator. So that's why this accumulator is a main register in which you have to store the data. So what this temporary register do is, suppose our timing control signal says that you have to add A with B. So now this timing control will activate this register B, and this B register data will come to the data bus, and this will be stored in temporary register. So internally how it works is that firstly the data of B is stored in the temporary register, and then accumulator and temporary register goes through ALU, right? And then the result is moved to the data bus, and then the result is stored to the accumulator, right? So in the meantime, this all things are happening, the program counter increments. So that this can be asked in the Viva as well, that what things happen, suppose they will give you the command like add ab, so you have to tell that firstly program counter, it will fetch the address through the address bus, right? And then the read signal like gets activated, that the memory read is activated, right? Suppose, so the address will go to the address bus, and the instruction which is fetched comes through the data bus, and it will stored in instruction register. Then it gets decoded, and the timing control signals are generated, right? And then in the meantime, this program counter gets incremented, right? So this was all about the block diagram. So the thing you might have in mind is, what are these pins? What are these pins? So actually these are interrupt signals, and this needs a separate lecture, right? So these things are discussed in the pin diagrams. So I think you might have started about the pin diagrams, or maybe I will make a video on pin diagram, right? um so you right now you don't need these pins while coding, right? So only thing you you need to know about these registers, right? And yeah, main important thing which I forgot to tell you, right? So we are working over 8 bits, right? Because we have 8 bit registers. But if we need to add 16-bit numbers, so what we can do is we can pair the registers. So in 8085 we can pair BC only, we can pair DE only, and we can pair HL only, right? We can't pair B and E or D and L. So this is specific, right? So if you want to operate on the pair of registers, the next thing is there are two more registers W and Z which user can't use. This is internal to the microprocessor. So this can also be asked in the Viva, that what two registers are used internally by the microprocessor and you can't use it. These registers are W and Z. Okay. So next thing which you need to know is, yeah, if the teacher asks that in which commands the microprocessor can use it, so you can say x chg. I think this is exchange, in which the content of register h is exchanged with the register d, and the content of register l is exchanged with register e. So this is specific to these four registers, right? So this exchange command exchange the contents of register D with register H, register E with register L, right? So here the temporary registers are used. How? Like firstly the content of H are gone to W and L are gone to Z, suppose. In the meantime, H register is replaced by the D register, L is with E register. So now D register will be replaced by W, and E register is replaced by Z. So I think you have done the program of swap or swap in C or C++, right? So this was a thing. So this is all about 8085 microprocessor block diagram. So thank you so much. In the next coming videos, we will install 8085 processor, and we will start our coding with some basic instructions, and with time we will do more instructions. So thank you so much for listening this lecture. So thank